You're gonna warm up a sausage.
When the sausage is heated, I will measure the temperature of the water and the sausage. Then Martin.
Then I will take the sausage and put it into calorimeter,
where I will measure the temperature and watch the heating up.
Now we will wait until the sausage gives all the heat to the water. Then Andrzej will measure the temperature.
And the temperature will be given to Honza.
So now we collect all the data from 5 measurements and do the calculation. Of course, we have to include uncertainties, with Pascal having 1/10 of degree and weighting machine having half a gram. And from this we can derive that the final relative uncertainty is 5%.
So when Bishi collected all the data, then we put it into the equation, which will be presented by Martin. Martin?
In this equation we have a lot of variables. For example, mass of water, specific heat capacity of water, final temperature of the water, initial temperature of the water, and on the other side of the equation we have the mass of sausage, specific heat capacity of sausage, which we are going to calculate, initial temperature of the sausage and final temperature of the sausage. If we express specific heat capacity for the sausage, we get this equation. And next to Andrzej, you have one example of data that we collected.
So we collected the data in the first experiment, and we had a mass of sausage 20 grams and mass of water 100 grams. That was our only variable that changed during the experiments. We put it into the equation, and the result was
2,489 joule over kilogram times Kelvin.
So to give you an idea what the result is and what it means, for example, the specific heat capacity of water is twice more than the specific heat capacity of sausage, and the specific heat capacity of sausage is twice more than of air, and it is 4 times more than of iron.
Nice!
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 Yeah.
project, we were interested what we are really drinking in our school refectory. By using radiated paper, we took some samples from each drink tank we have in school refectory.
In this beaker you can see that we have found there some visible physical objects. You can watch them, and here is a sample of what we found in there.
So we found some protozoans,
molten fungi, amoeba,
flagellates.
So our project also had like greater impact on the school because we showed our results to the school management, and they decided to clean the tank.
So, our group was measuring the flow rate of water in the water tank in the school cafeteria, and we measured the correlation between the amount of water left in the tank and the flow rate, which was our dependent variable.
The way we did this experiment was that we always let 1 liter of the water in the tank flow away, and we measured the time in which this was done.
We should fill our glasses when the tank is full, because we will save some time.
And if you don't waste some time, just when you see the tank is not full, just refill it and then get your glass full.
And don't think that it's just a matter of 2 seconds, the difference. The difference is in fact great. You can wait up to 15 seconds more when the tank is almost
Per 1 liter.
empty.
So with fast measurement you save 15 seconds of your life.
In our experiment, we were interested in what lives in our school canteen and in the equipment that we have there. So we have taken samples from several items, like hands of the cook, trays, cutlery, table and glasses. The samples were taken like this, with the help of this stick, like then we put what lives there on the agar plate, and we put it into the incubator for 1 or 2, maybe 3 days. And after 3 days,
And after a couple of days, actually some molds developed on those agar plates. When you look at that, you can see that the most dirty are actually the tables at the school canteen, and also the cutlery aren't really in a good shape, as you can see. And actually most clean are the glasses we have in the school refectory.
there is only a small amount of mold.
Yeah, almost nothing. So that's what we have found.
So we were trying to measure the sound levels in the school refectory. For this we used the Pasco Explorer and the sound level probe. And we were trying to determine where the greatest noise levels are in the school refectory. So we tried to measure that in the front of the refectory, right in the middle and in the back. And we found out that the greatest noise is in the front of the refectory, where the food is served. During this we also found out that the class that makes most noise is the first grade, the smallest children, the youngest ones. They're making far more noise than the teachers. And we were also trying to find if the sound levels, the greatest noise levels that are here, are not damaging our sense of hearing. But we found out that the exposure to the sound that was there as the average, which was about 75 decibels, is quite normal. The exposure to the 85 decibels should be allowed to like 8 hours till it gets dangerous, so nobody is actually threatened in the school refectory.
Our group was influenced by one option which is in our IB biology book. The option is human nutrition and health. So we did a research and calculated values of energy and calories in food which we daily eat in our school canteen.